Hello, everybody. We are going to start a quick flash unit on sequences. So, very first lesson, explicit formulas for arithmetic and geometric sequences. That's a lot of words that maybe you don't know what they mean. Let's figure out what they mean. If it's an important vocabulary word, I put it in all caps in your Desmos file, and you should put it down in your notebook. You should say this phrase. You should try to use it in context, and it will increase your knowledge of the subject matter. So let's get started. First of all, a sequence. Sequence is just a list of numbers, all right? 5, 6, 7, 8. Who do we appreciate? Mr. Zamora, of course. All right, that's a sequence, 5, 6, 7, 8. A sequence is just a list of numbers. And we're gonna look at two particular types of sequences in this unit. The first one's called arithmetic sequences. All right, so here's an arithmetic, and if you want to be fancy, you can call it an arithmetic sequence. So the arithmetic sequence, 4, 7, 10. There, you could probably find the number after 10. It's 13, right? 4, 7, 10, 13. You can probably find the number after that. So this is an arithmetic sequence. The reason it's called an arithmetic sequence is because it contains what you know as a common difference. The common difference very well could be self-explanatory, because everyone can tell, or most of us can tell, that the sequence, the pattern is that you're adding 3. 4, 7, 10, 13, 16, 19, etc. You're adding 3. So that plus 3 is known as the common difference. The common difference is the difference in between the terms. All right, you find it by finding the difference between the terms by subtracting. Right, that is what makes an arithmetic sequence. All right. When you think arithmetic sequence, I want you to think linear function, because linear functions had a common difference in between the outputs. All right. Next, how do we find the explicit formula? What exactly is an explicit formula? So an explicit formula is like the equation that describes this sequence. It's like finding the equation to a linear function. All right. So to find the equation, we actually have this funky formula that is actually just a fancy way of thinking of mx plus b. All right, but let's see how this turns out. So the formula is a sub n equals a sub 1 plus n minus 1 quantity times d. All right, now a sub 1, that means the first term. All right, so think of a as terms. All right, it doesn't mean that it's a variable. A sub 1 simply means the first term. N refers to a term number. For example, if n is 5, we're talking about the 5th term, or the 5th number. If n is 10, we're talking about the 10th number. And then there's d. D is the common difference. So I'm going to fill in all my information from the sequence that was given. So my first term is 4, and then I'm going to keep it as n minus 1 because I'm trying to find the actual rule, the equation. And then my common difference is 3. So 4 plus n minus 1 times 3. Some problems will ask you for the explicit formula, and you're done right there. That's fine. Other problems will ask you to simplify it. So let's simplify. I'm going to distribute the 3 to the n minus 1. So I get 3n minus 3. And I've got 4 plus 3n minus 3. I can simplify 4 minus 3 as 1. So this is really 1 plus 3n. Now, let me do a little bit of magic right here. If I graph 1 plus 3n, take a look at it, all right? Really, if I graph even from the unsimplified, right? This really looks like the function with a y-intercept at 1 going up 3 over 1. And that's because it is. Now you might ask, well, I don't see a y-intercept of 1. And that's because if you go back 3 from 4, if you go back 3, you would get 1. 1 is like the 0th term. We don't see a 1 because a list begins at the first number, not at the 0th number. So that's a little difference between sequences and functions, right? That we're really worried about starting from the first term, not the 0th term, okay? So anyway, the way that you use this formula, either one really, the unsimplified or the simplified, is you can substitute. That's the purpose of an explicit function, that you can substitute any value, all right? So I'm gonna substitute 15 into my formula. 1 plus 3 times 15 is 46, or I can use the unsimplified one. I say 15 minus 1 is 14. Then 14 times 3 is 42. 42 plus 4 is 46. That's how you use explicit formulas for arithmetic sequences. I don't know where my face went.